Solving equations using logarithm. You can use logarithms and your calculator to solve equations in the form of a to the power of x equals to b. Let's solve an example here. Example 1. Solve the following equations giving your answer to 3 decimal places. A. 3 to the power of x equals to 20. We know that if log to base a b equal to c, then b is equals to a to the power of c. So we're going to use the same concept to solve equations such as 3 to the power of x is equals to 20. So would be log to base 3, 20 equals to x, or x equals to log to base 3, 20. Using our calculator, we should get x equals to 2.727. For the first example, I show how to use calculator. However, in previous videos, you already learned how to use the calculator to calculate logarithm. So, log, we need 3 here, 20 here. So we can clearly see it is 2.7268 and so on. So up to 2 decimal places, it would be 2.727. Okay, next example. 5 to the power of 4x minus 1 is equal to 61, which becomes log to base 5 of 61 equals to 4x minus 1. Okay, or 4x minus 1 equals to log to base 5, 61. Here, our aim is to work out the value of x. So let's not work out the value of log to base 5, 61 first. Let's rearrange everything for x and get the exact, more accurate value basically. Which becomes 4x equals to 1 plus log to base 5, 61. And finally, x equals to 1 plus log base 5, 61 all over 4. Using our calculator again, so it is a fraction 1 plus log to base 5, 61 all over 4, which is equal to 0.8885 and so on. So therefore, x is equals to 0.889 to 3 decimal places. Okay. Let's move on to a little bit harder example. So let's draw a line to separate questions from each other. Okay. Example 2. 5 to the power of 2x minus 12 times by 5 to the power of x plus 20 equals to 0. We want to work out the answer to 3 significant figures. Okay, so in first look, the Question looks so complicated. 5 to the power of 2x minus 12 times 5 to the power of x plus 20 equal to 0. So this one was quite easy and straightforward. We had only x in one side of the only as a one term basically. But here we've got x here and here in two terms. But it's easier than what it looks like. So in fact, these sort of equations are hidden quadratic. I could write down 5 to the power of x in the bracket all over to the power of 2 minus 12 times 5 to the power of x plus 20 equals to 0. To solve this, we could use substitution method. Let y equals to 5 to the power of x. We could rewrite our equation as a y squared minus 12y add 20 equals to 0. Okay, so factorizing this one, we get y minus 10 times by y minus 2 equals to 0. Therefore, y equals to 10 and y equals to 2, or y equals to 2. But we know that y is equals to 5 to the power of x. Therefore, 5 to the power of x equals to 10, or 5 to the power of x equals to 2. When 5 to the power of x is equals to 10, it means the log of base 10, base 5 to base 5 of 10 is equal to x. And similarly, log to base 5 2 equals to x. Therefore, using our calculator, log to the base of 5, 10, which is 1.43 to 3 significant figures. And this one would be 0.431 to 3 significant figures again. Okay, let's go through the example 3 and last example. Okay. Example 3. Find the solution to the equation 3 to the power of x equals to 2 to the power of x plus 1. Right. This one doesn't look like any of the previous equations. So we've got 3 to the power of x. Both of them are not 2 to the power of x, so 2 to the power of x plus 1. Okay, so therefore we cannot apply the same method as we applied here. And as there is x in both sides of the equation, we cannot apply the same rule. But we can take log of the same base from both sides. If a is equals to b, then log a must be equals to log b with the same bases. So this is another probably useful formula. If a is equals to b, then log a to the base 10 or any base is equal to log b to the same base. If we choose base 10 for a, we have to choose base 10 for b as well. Okay, so therefore we can say log 3 to the power of x is equal to log 2 to the power of x add 1. Okay, so I keep writing here just to save a little bit of space. So x, both of them has got the base of 10. X equal to x times log 3 using the powers law would be equals to x plus 1 times by log 2 to the base 10. Okay, let's expand this one. We get x log 3 equals to x log 2 plus 1 times log 2 is log 2. Therefore, x log 3 minus x log 2 is equal to log 2. Factorizing from log, we get factorizing from x, we get log 3 minus log 2 equals to log 2. And finally, x is equals to log 2 divided by log 3 minus log 2. Using our calculator, we get equals to 1.7095. Okay. So after this lecture, you should be able to do exercise 14F, page 325, and yes, 325, which are 4 questions. Okay, however, just to mention this, it follows the Excel textbook. Okay, so Excel year 1 textbook.